Hey everybody, for this video we will be talking about compound interest. There'll be some application problems and I will be showing you how to do how to use your calculator. And I want to start out with two different types of interest. We first have simple interest, which is just the interest equals P times R times T. So that's very simple interest. Compound interest is different. With compound interest, we start with a principal, say $100, and let's say we have an interest rate of 5%. Well, 5% of $100 is $5, so after a year, you get $5. Now, if this was simple interest, these would all be $100. But what happens is that new amount becomes your new principal. 5% of 105 is $5.25. You'll notice that's now more money that you're earning on it. It's compounding it. You then add that to the principal. That becomes your new principal here. 5% of that is here. You add that, and so on. So you can see it's going to go up faster. That's good if you have an account. It's bad if you have a credit card debt. Here's our two formulas that we will be using. This one here and this one here. And I want to break this down a little bit. You can see it gets a little complicated. The A here stands for the total amount after so many years. P is the principal. That's the original amount that was put into the account. T is the number of years. And I want to explain N for a second. N is the number of times that it's compounded per year. So if you say that it's compounded annually, that means that it's N equals 1. If it's compounded semi-annually, N equals 2. If it's compounded quarterly, N would be 4. If it's compounded monthly, N would be 12. Daily, 365, and so on. Now, what happens is if we do keep upping N and make it bigger and bigger, so maybe hourly, by the minute, by the second, by the nanosecond, and N goes off to infinity, well, this formula up here becomes this formula here. They look quite different, and I need calculus to convert from here to here, so that's outside the scope of this course. But I do want to point out that the A, P, R, and T are all the same, but E is, if you look on a calculator, it's the number above the LN button. So for mine, I have to activate the blue button first to get to it. It is actually, it is e to the first power, is about 2.7 and change. It's one of those useful numbers that sort of pop up all over the place in real life, especially in higher level like in calculus. So we have two examples here. First off, we're going to be compounded quarterly. That means N is 4 in that case. The original principal is $300. The interest rate is 0.075. We convert from 7.5% to a decimal. And for 4 years. And we dump it into here. Now I want to show you how to use your calculator. It's important that you practice this. We're going to use order of operations and we're going to start on the inside. So division comes first inside. So 0.075 divided by 4 equals plus 1 equals raised to the 16th power, that's 4 times 4, equals, you'll notice I'm hitting equals in between each one, times 300, equals, giving me $403.83. Now, it's really good if you break it down like that very slowly. If you try to cram it all in at once, there's a good chance that you'll make a mistake, so I would strongly recommend that you kind of do what I just did. Next up, we're compounded continuously, so we're going to use our continuously compounded interest formula. And our original amount is $500 with an interest rate of 6.7 or 0.067. And we're going to go for 6 years. So we plug everything in. And once again, I want to show you how I would do that. So second ln will get me my E. Now I'm going to use parentheses. 0.067 times 6. Close parenthesis, equals. Now, times 500. And here's my $747.41. Again, make sure you practice that. And here we have compound interest, part 2, the sequel. So, this problem is, we have $3,000 on this date is placed into an IRA that will pay 7.5% annually compounded continuously. So we're going to be using our continuously compounded interest formula. And they want to know what the IRA will be worth in 2022. Now, to get the time, the t in this case, I have to subtract the 2. And you can see that's what I did here to get my 15. The principal is $3,000. 7.5% is 0.075. And we plug all that in. And let's walk through the calculator. I'm going to start with the E, second ln. And I'm going to use parentheses, 0.075 times 15, close parenthesis, equals, times 3,000. You can see that comes out to be $9,240.65. Next up, we are going to find the APR, the annual percentage rate, called here the effective annual rate of interest. And what we're going to do first is find out the interest for 1 year. So it's still the same setup. So for 1 year, we're going to find out what that interest is, and then compare it to what if we were to, if it wasn't continuously compounded, what if it was simple interest compound, not compounded, it's just simple interest. So I'm going to go second ln. It's raised to the 0.075 power, just 1 year, times $3,000. Now that's going to be the total amount you can see after 1 year. What I need to do is I want to know how much interest was earned during that year. So I'm going to subtract the 2, so minus 3,000. So this is the amount of interest earned in 1 year using continuously compounded interest. Now what I'm going to do is I'm going to say after 1 year, had it been simple interest, here's the interest equals the principal times the rate times the time, which we saw this formula on the first page, right here, interest equals P times R times T. Here we are. And we're going to plug in our interest, our principal, and our time. So this is basically going to be 233.65 divided by 3,000. So divided by 3,000. And so here's our APR, our annual percentage rate. After converted to, by multiplying by 100 to move the decimal in 2 places to get a percent. So 7.79. This is compared to, so I can get both there, this with our compound interest, continuously compounded. So number 3 says find the principal needed now to get each amount, that is find the present value. Meaning if I want $200 after 3 years compounded daily at 5%, what do I need to put in now to make that happen? So we have A. This is the amount that we know that we want in 3 years. We have 3 years. We have the interest rate is 5% of 0.05. And N in this case is 365 because it's compounded daily. So we plug everything in. And let's walk through this. Move over here. So 0.05 divided by 365 equals plus 1 equals raised to the, and I'm going to use parentheses, 3 times 365. Okay, so this is the amount, and you saw the numbers as I was doing that. I now have to divide both sides by that amount, by this value here. So I'm going to show you a little trick. If you see above the negative button, it says answer. This is the previous answer. So I'm going to do this. I'm going to do $200. So I'm doing this right here. Divided by, and I'm going to hit second, and I'm going to go down here and hit answer. And what that does is it takes the previous answer. Equals, and there's my present value. Meaning this is what I would need to invest today if I want in 3 years $200 at this rate compounded daily. I'm going to skip over to here. Now, they want to know how long it's going to take for the money to double at 4.5%. Well, double means that A in the formula is 2p. We're literally doubling the original principal. So A becomes 2p. You'll notice, we also dumped in the interest rate. You'll notice that I can divide both sides by p so that I'm now down to one equation with one unknown. I then take the natural log of both sides. That brings the exponent down. And to get t by itself, I have to divide both sides by 0.045. So I'm going to do that right now. ln of 2. Now make sure you close your parenthesis if your calculator needs that. You could even hit ln 2 equals and then divide by 0.045. And you can see that's 15.4 years.